Hello everyone. First of all, I want to thank all of you for attending this interview today. Uh, Thank you to Mr. Han, Mr. Awwal, Mr. Ari, and Ms. Vio.
It is our pleasure to attend this discussion today.
So today we will discuss about batteries and its innovation. Can you explain to us what battery is, Mr. Awwal?
Okay, thanks for the question, Mr. Bagus. So basically, batteries is a group of electrochemical cells connected in series and parallel. There are many types of batteries, such as household, industrial, and vehicles batteries.
Are our batteries today sufficient to fulfill our needs, or do they need improvement?
Based on our data, batteries that we have today is sufficient to fulfill our needs, but every batteries share common problem. They need to be recharged that could be troublesome in some situation.
So, what kind of improvement that we need today?
The answer is very simple. We need a battery that doesn't need to be recharged.
And how can we achieve that? Is there any innovation in this field?
Nuclear battery can solve that.
Can you give us the reason behind your statement?
Of course, it converts alpha, beta, or gamma radiation into energy. And because radiation depends on the half-life of the element that we use, and usually it's quite long. For example, plutonium has a half-life of about 88 years. Nuclear battery could last for years without needing to recharge.
There are a lot of radioactive material. Which one is the most promising material if we want to build a nuclear battery?
Good question. Plutonium 238 is one of our answers right now.
Could you tell us about plutonium-238 characteristics?
Alright. Plutonium is a radioactive material that can produce a alpha particle. Alpha particles are a particular type of ionizing radiation that can be shielded by material as thin as a piece of paper. Plutonium 238 is not the type of plutonium used for nuclear weapon and would not work well as a fuel in a nuclear reactor. This day, plutonium-238 is applied by NASA as a radioisotope power system.
That's very good. Do plutonium-238 have any problems right now?
Of course, it does. Plutonium-238 has case and life-limit stockpile of this incredibly useful and relatively long-lived fuel. According to a report from popsci.com, there is only enough left plutonium-238 to make 3 more nuclear batteries, or called as the multi-mission radioisotope thermoelectric generator, or MMRTGS.
Does it already have solution?
Fortunately, it already has. We figured out how to produce it ourselves and to harness it to create a remarkable persistent source of energy.
How does it work?
Same as other radioactive material, plutonium-238 is an unstable atom. Plutonium-238 decays spontaneously, and when it decays, it fires off helium core at high speed, which called alpha radiation. The energy can cook a pot of plutonium-238 to nearly 1260 degrees Celsius. Then we wrap the pot with thermoelectric that convert heat to electricity. But it is not efficient and costs a lot of money.
Amazing. So, from our discussion today, we can conclude that we need a huge amount of energy, which have to be good for the environment too. One of our answer is nuclear battery, because it is long lasting. Plutonium-238 is a reliable materials, but we need to develop it because its amount is depleted around the world. I want to say thank you everyone for coming to this interview.
Thank you.
Thank you.